It happened. Elon Musk just revealed a new nuclear reactor. Nuclear power. We all have heard this before, like they can be used to generate power, fuel, energy, but the only problem comes is that they are super dangerous and heavy. But Musk is building a portable nuclear power generator. This power generator is a lightweight, cost-effective micro-reactor. Want to know more about this? Well, stay tuned to the video and watch the video till the end. Hello guys, welcome to Space Live. Hit the subscribe button and turn on the notifications to get new updates about space, Musk, technology, and basically anything about science. Hit the like button to show your love. And in today's video, we are going to discuss the new nuclear reactor by SpaceX. So without wasting any time, let's begin. Former SpaceX engineers have created the world's first portable zero-emissions power source that can be quickly installed in cities and bring power to remote areas. According to Bernauer, who is a former SpaceX engineer who worked on developing energy sources for a Mars colony, micro-reactors offer the most promise for supplying power to settlements on Mars. He saw an immediate opportunity to use the technology on Earth, which led to the founding of Radiant with two other SpaceX colleagues. In the past, SpaceX has built some amazing machines, but apparently, for some engineers, revolutionizing space isn't enough, and these engineers have formed Radiant, which is a new startup. They promise space-grade micro-nuclear reactors that will revolutionize portable sustainable energy. Last year, Radiant announced having received 2 provisional patents for its portable nuclear reactor technology. One patent covered the cost and time of refueling their reactor, while the other addressed heat transfer efficiency from the core of the reactor. Among other reasons, some say fusion is a safer way to generate nuclear energy due to the fact that fission produces long-lasting radioactive waste, while fusion does not. But the problem is, with today's technology, fusion consumes all of its energy to sustain its reaction and leaves nothing for other things to be powered by. It has not been possible to commercialize fusion so far, despite efforts by a number of companies. Therefore, Radiant last month said it had raised $1.2 million in angel investments to create a mobile power generation system. Radiant's nuclear reactors use helium instead of water to cool. By doing so, corrosion, boiling, and contamination risks are greatly reduced. These reactors use particle fuel that does not melt, according to Radiant, and can also handle higher temperatures than traditional nuclear fuels. The company is also working around ways to refuel the reactors and also efficiently transport heat out of the reactor core. However, the micro-reactor will use an advanced particle fuel that will not melt down and will be able to withstand higher temperatures than traditional nuclear fuels. At the same time, helium coolants reduce corrosion and contamination risk associated with traditional water cooling systems. The Radiant company has signed a contract with Battelle Energy Alliance to test its portable microreactors at the Idaho National Laboratory, INL. Earlier this year, INL selected an Oklo microreactor to receive high-assay, low-enriched uranium fuel from the lab that supported a first-of-its-kind demonstration of Oklo's Aurora microreactor. Radiant is looking forward to working with the National Reactor Innovation Center, NRIC, to test its portable nuclear microreactor at Idaho National Laboratory. As part of our mission to empower innovators, we strive to deliver successful outcomes. Dr. Ashley Finnan, director of NRIC at INL, said that this is an opportunity to innovate in ways that bring a cleaner energy future. But aside from that, the actual use of microreactors is to expand distributed power generation. It's as part of a trend to provide electricity to remote areas, military bases, and commercial operations that lack access to grid power. Bernauer said, "Cost optimization is a reduced power peaking factor of our design," noting the microreactor's portability provides freedom and optimization. And one of the benefits of the portable system is that it's so small we can autonomously operate it. Radiant claims its microreactor can power 1,000 homes continuously for 8 years, be transported by air, ship, and road because it is designed to fit in a shipping container, single high 8 feet by 20 feet, 9.5 feet high. The company has said its microreactor is also safer than traditional nuclear power plant designs, leveraging particle fuel that withstands high temperatures and does not melt down. The use of helium coolant greatly reduces corrosion, boiling, and contamination risks associated with more traditional water coolants. In most water-cooled reactors, nuclear fuel is cooled by water. Water then turns to steam that drives a turbine that creates electricity. It also acts as an effective absorber, blocking neutron radiation from leaking out of the reactor. But the slow part is the crucial part. The fuel they use requires neutrons to be slowed down in order to create a chain reaction, so these reactors can't get too hot. They do this by packing moderator material within the reactor that takes energy out of the neutrons, typically a combination of heavy water and graphite. However, the requirements needed for these reactors, such as huge cores with plenty of moderator material and extensive cooling systems, access to lots of water, and giant vats of water around the reactor, make these reactors very large. But water cooling is only effective for low-temperature reactors. If you want your core to exceed 1800 degrees Fahrenheit, then you need to switch to gas cooling. However, helium is very stable, inert, non-flammable, and has a very high thermal conductivity. This means it is an ideal candidate to use as a reactor coolant. So, rather than water turning to steam and powering a turbine, helium is blown over the reactor to heat it up so it expands, which pushes it through a high-speed turbine, making electricity. The helium is then recycled. A high-power refrigerator cools the helium back down and then re-enters the reactor. But, on the other hand, they also likely use a fast reactor type of fission. These reactors use nuclear fuel, which can use fast neutrons, so they don't need any moderator material, which makes them much more compact. However, these reactors run at much higher temperatures, around 2000 degrees Fahrenheit. Furthermore, these fuels have another distinct advantage over their uranium-235 counterparts. They can breed more fuel. The higher temperatures mean that fuels such as thorium-232 can absorb neutrons and transform into uranium-233, which has far less radioactive waste than 235. So the longer the reactor is active, the more these fuels can breed and transform into more usable nuclear fuel. There are several options for fuels like this. The main ones are thorium and plutonium, and Radiant could use either in their reactor. There is a huge demand for micro and modular reactors on Earth, so it is likely Radiant will have plenty of customers, meaning they will have the money to develop their reactors properly, and this will give them a gigantic leg up on their competitors for space reactors such as Rolls-Royce, SpaceX, and Boeing. But Radiant reactors could end up powering lunar and Martian bases or complex space infrastructure such as skyhooks or orbiting zero-G pharmaceutical factories. So even though we have speculated what technology is within Radiant's reactor and could be way off the mark, there still remains an exciting development. Radiant could revolutionize not just portable energy, but also domestic energy. Having such a clean-running, modular and compact nuclear reactor could be the key to unlocking our carbon-neutral future. Only time will tell whether Radiant can deliver and produce this incredible piece of technology. But what do you guys think about this? Let us know in the comments section. And that's it for the day, guys. Thank you for watching the video. We hope you liked the video. If you did, then leave a thumbs up and also consider subscribing to the channel. And also, guys, don't forget to press the bell icon to never miss any updates from us. See you in the next one. Until then, peace.